So today I'm looking at a Hamilton Beach slow cooker. Set and forget. I think somebody else uses that phrase. Anyway, apparently it's dead, and we're going to take a look, see what's up with it. Model number is, let's see here, 33960, type SC17, series E1530AS, Hamilton Beach Proctor Silex Inc. And it's a 120 volt 330 watt slow cooker. There's a dent in the back end of it, which may or may not be one of the problems, if not the problem. Looks like it's taken a clout in the back end there. That may be an issue. There's a couple of other little dents here and there, but that's pretty normal wear and tear, I would imagine. And it's lost a foot here, or part of a foot compared to this here, so that's not going to stop it functioning, but it might make it unbalanced in terms of its when the liquid or whatever inside it's coming to a level. That may be a problem, but that's not something I'm going to worry about right now. So anyway, it looks like these screws here, or these nuts, are how we get into the thing, and those pop rivets, I would imagine, hold those things in place at the top here. So just need to get those loose underneath there and see what's going on inside. So I'm going to put a little bit of WD-40 on each of these to lube them up a little bit, because I suspect they're going to be pretty tight. So hopefully that will free them up a little bit and won't give me too much of a struggle. So I managed to free these up with some pliers, and they're coming off pretty easy now, giving them a little bit of lubrication. So continue to remove these and see what's going to go on underneath. So both a nut and a washer. I put the parts here into a magnetic tray so I don't lose the screws. So it's a good idea to keep those in one place, or at least keep them organized, so you know where they need to go. And then if you don't finish a project, if you're still working on a project and you haven't finished it, what I use are medicine bottles to keep the screws in, and then I'll either write on the medicine bottle, or I'll just keep the screws with the project itself if I need to wait for parts, or the following day or whatever. At least I know where the parts are. I meant pill containers, not medicine bottles. These with screw tops, or the childproof tops, because they make handy little containers to keep screws and odds and ends in. I mean, if you have enough of them, I guess you could keep a selection of resistors in these. sorted in a box. But yeah, that's what I was talking about, not medicine bottles. So anyway, the screws are out, so that's a start. I suspect I can now lift this off the other part of the body here. So anyway, it looks like the heating element goes around the body of the aluminum part on top, and then we've got what looks like some sort of heat sensor here attached to the bottom, the underside of the aluminum container, and then the connections on the other side. Oh, and also a couple of spacers that have dropped. At least one spacer. Oh yeah, two spacers and a couple of washers that need to go on these bolts when it's reassembled. So I'll take those out of there and put those safe. What I'm not seeing, which I'm a little bit surprised at, maybe that's a thermal fuse of some kind, not a thermostat, but what I'm not seeing is a fuse, which surprises me. And I don't think that dent caused any issues. I don't see any flashovers from shorts on the metal there, and corresponding part of the unit here. I don't see anything shorted out, so appears to be okay. So I don't think that was the problem, but it looks like that's got pretty warm, and maybe an issue. Right now I'm not sure whether that's a thermal fuse or a thermostat. It's got to be able to sense, I would imagine it has to sense the temperature, so I'm not sure how it does that, unless, sorry about the noise, unless that is a some sort of thermal sensor underneath. There's the two contacts for the element, and it's sprung tension around the aluminum part here of the slow cooker. So it looks like I've got to delve inside this control unit somehow. Looks like there's a couple of screws on either side that I need to undo to give me access into the control panel, and we'll go from there. I took those 4 screws out, but I noticed there's 2 more down there in the center of the unit, so I'm going to pull those out next. Well, now I've got the front panel loose. There's a couple of screws, actually there's 3, there's one down the bottom there and one there, so there's three screws, it looks like, holding this front panel together. So it looks like it'll separate around here from this back piece, and that will give me access to the controller, hopefully. Well, this thing doesn't want to come apart. I'm not sure why, but it doesn't want to separate. The 2 halves of this plastic here don't want to separate. I know the element wires and so forth are coming through the hole here, but that doesn't seem to be what's holding things up. This is fairly loose at this end, but I'm wondering if there's anything underneath this front panel, but the front panel is glued on, and I'm hesitant to remove that front panel with the touch controls, well, not touch controls but button controls and LEDs, but it may need that part to be removed. There's possibly more screws underneath there, so I might have to investigate that. But these parts don't want to separate, so I'm thinking there's something. I see a screw down inside there that I can't get at the moment. Maybe that's some sort of heat sink, or possibly a chassis, because it seems to run along at least some of the inside here as that aluminum part attached to it. But anyway, I'm gonna have to flip it over and have a look, see if I can get underneath that front panel somehow. Well, I just lifted this front panel here, and all this has underneath it are little plastic, you can't really see very well in that light, but all they are just little plastic buttons that must push through to the board, the switches underneath. So it looks like there's nothing here on this part that gives me access to the control panel, so it's rather mucky. But anyway, so this isn't going to help, so I'm going to have to stick that back down if I can actually fix this unit. It's not really it's not really worth spending any time on it, but it's more a challenge than anything, you know. It's just something that I happened to come across that needed fixing, so I thought, oh well, we'll take a look at it. I mean, whatever I can do to it, it's going to need quite a hell of a clean up afterwards. I'm surprised so much of this is steel, actually. You know, from the rust you can see this band around here is steel, not aluminum. And I guess that was a cheaper way of manufacturing it rather than using aluminum. So anyway, yeah, this control panel's giving me a hard time getting the thing apart, so I'm going to take another close look at it and then continue recording. Okay, well, I finally got the thing apart, and the front cover isn't actually attached to anything, but this piece just didn't want to come away. But anyway, I guess something was holding it in place, so I finally got that off, and now I can set about see what's going on. There's not an awful lot inside here. This looks like AC in at that point there. Focus, thank you. There's something sensor there, so I would imagine that's that thermal sensor we were looking at earlier. I don't see any signs of scorch marks and damage. And the heating elements, I think the heating element actually is one side, I think goes directly to the mains input, if I'm not mistaken. Sorry about the clanging around. So well, I could be mistaken, because there's a third wire there coming in from the mains, but for some strange reason it's just a two pin plug on the end of this, so there's no ground wire. So I'm not quite sure, maybe they just took Maybe they just took a neutral off here and split the cable. Actually, that could be where the problem lies, where it goes to that strain relief. Maybe it's just been flexed backwards and forwards too many times, and the strain relief has, or it snapped the mains cable where the strain relief comes through the unit. So yeah, the one wire looks like it comes straight from the mains. So I'm assuming that's the neutral wire that goes straight up there, and then they switch to live in the control unit. So I'm going to see. Yeah, that's the other wire to the element, that red wire there, which comes off that control board. So they must be switching that line on the control panel. And like I said before, that's some sort of sensor which has been getting pretty warm. And I don't think that's the problem, but it depends whether it's a thermal sensor to test if it's overheating or not. It could be some sort of thermal fuse, but I think, you know, it may be just some sort of thermostat. So anyway, let's continue to investigate the what's going on here. So the AC comes in on those two lines, and looks like MT1 there goes right across to the other side. So it looks like I need to get the meter out and start doing some tests here and see what's going on. I'm going to do some resistance checks, some continuity checks of the wiring, and make sure the AC is actually getting up to this point here on the board. Because the thing's totally dead, I suspect possibly the strain relief, some sort of break right at the strain relief there, rather than anything else. So now I've got access to see where the wiring comes in. I'll just do some continuity tests and see what's going on. Plug to one of the AC connections down here on the board, and there is continuity right there. Let's just check that again. Yeah, so I've got continuity. Actually, that was shorting out, so shorting the live and neutral. So I'm gonna just reposition that, do it again. So here we go. So yeah, so there's continuity to the one side of the plug. Now if I switch that over one-handed, which is always tricky, let's do it that way, and we should have continuity here, which we do. Our meter's pretty slow, but anyway, yeah, we have continuity. So it's not what I suspected, which was the cable restraint. So I've got to get a little more technical and start doing some measurements. But I was just looking here at the switching device that's on this on the heatsink here, and I couldn't see it on the top of the board, so I knew it had to be underneath here, attached to this aluminum heatsink. So I can't really see what it is. It's not going to focus on there, I don't think. Oh, there it is. Still can't really tell what that says. Looks like L400 something something something, and that might not even be the part number. But anyway, I'd imagine it's some sort of thyristor, triac, or FET device, switching the power to the element. I'm going to do some more tests actually, some resistive tests and diode tests on the board before I actually do some voltage tests. Just having a quick look at these capacitors here, they look okay. Doesn't seem to be any leakage from these, physical leakage. And the tops are not swollen, so I'm not going to worry too much about those at this point in time. But it looks like it uses a capacitor dropper type supply, and so I'm going to have a quick look at that, measure around there to see what's going on, because the thing's dead. Then it could well be the capacitor, the capacitive dropper. Oh, mosquito, first of the season. Wow. Gotcha. No, I didn't. I thought I got him. Alright, so yeah, it looks like there's some sort of capacitive dropper circuit here to power the unit. So I'm wondering if there's anything around here. What's that? That little dot. That should be a 24 ohm excuse me, 24 ohm resistor. And it's probably well worth checking that, see what that little dot is. Maybe just a little chip in the porcelain on that resistor there. But that could be a prime candidate, so I'm going to do a little bit of testing, see what that measures. Certainly a possibility. Let's have a look here, see what it measures in circuit. Whoa. 6.8 meg. Yeah. Yeah, that's not good. Across what should be a 24 ohm red, yellow, black and gold for the tolerance band. So yeah, 6.8, 6.8-ish. Oh, I just fell off the connection. Let's check it again. It's around 6.8 something. Yeah. Yeah, so it looks like that resistor's open circuit. Well, that's a quick fix if that's all that's wrong with it. But has it gone open circuit for a reason? Possibly feeds this diode here, or a couple of diodes. So I'm gonna do some diode tests on these just to see how they measure up. That'll be the next step. I really do need to get a tripod or something that's going to hold the camera for me, because doing measurements with one hand is virtually impossible on components. Yeah, that's pretty tricky unless I actually use some clip-on leads. Actually, I could use some clip-on leads right now. I think I'll get those. So I just switched to a different meter for checking that resistor, and that meter is a lot quicker to respond. So if it's not connected right now, so if I connect it up, it's going to tell me a value almost instantly, I hope. Yeah, I mean, look how quick that is. Roughly 6 meg. So that resistor is definitely toast. So that will be coming out of there shortly. Now checking that diode D2, and it appears to be fine, about 0.6 of a volt drop across that diode, so that looks to be fine. Let's check this one down here, and see, need to check it that way around. Yeah, around about 0.6. There's another diode there. Not sure what that is. Maybe it's a Zener. Can't quite see the number on that, but anyway, yeah, it's still showing a diode junction. And just to see if there's anything the other way around. And it looks like there's a capacitor charging up, so yeah, I'm not worried about that. Alright, so there's other semiconductors over here in the PIC controller that it uses to control everything. So it looks like that's our prime suspect right there, that 2.4 ohm resistor. So I have to see what I've got in, not 2.4, 24 ohm, sorry, 24 ohm resistor. I'll have to see what I've got in stock and replace that and see what happens. So I've just been looking through my parts and I can't find a 24 ohm resistor, unfortunately. So I might order one, but for now I think I'm going to try the 30 ohm. It shouldn't cause any failures, but it might not give it enough power. But I don't want to put the 20 ohm in, at least not at this point. I think what I'm going to do is order one. I'd build one from multiple resistors, but I can't get it to fit in there very easily. So that's a problem because it's a 2-watt resistor, and the physical space that it's got. I can't really make one easily to fit in that space. So I'm going to try the 30 ohm. Most of these actually measure 29 ohm, and most of these measure about 19 ohm. So I'll find the lowest one of these. I'll select the lowest resistance of this bunch and try that. And then in the meantime I'll order a 24 ohm or a bunch of 24 ohm resistors that I can keep with these 2-watt resistors. To get to the underside of this board, I had to remove 2 more little screws that were screwing the holding the board down to the to this plastic here. So I took those out, and you can see the heatsink is now flopping around in the breeze. And I'm going to use my Hakko 808 desoldering pump to take this resistor out. Something that I really can't do without the Hakko. It's so useful, and they take the solder right off the component really quickly. And it's going to be a bit difficult to get in. It's going to be a bit difficult to get down there to the other end. So I might just melt that and pull it out with some pliers. Might be the easier way to get the other end of that resistor out. Okay, well, it's out. So now I'm going to just tack that 30 ohm resistor in its place around there, the centre of the board there, or the centre of the camera shot, I should say. And just confirming it is a 30 ohm resistor while it's measuring 29.7 and about 0.5 for the meter lead, so it's about 29 ohm resistor that I'm going to put in there. So for now I've just tacked that 30 ohm resistor in that place of R11, which should actually be a 24 ohm resistor, but for now I'm just going to try it with that 30 ohm resistor and plug it in and see what happens. I've got it plugged into my, well, I will have it plugged into my isolation transformer. So here we go. That's the isolation transformer over there, so I'm going to plug into there and check things out once it's plugged into the isolation transformer. Plugging it in now. Oh, not quite plugged in. Yep, okay, now we're plugged in and we have some life. Now I know normally, let's get the front panel so I know what I'm doing here. Alright, so well, it's not getting warm yet, so I guess it's the element's still turned off, but I imagine if I press either mode or time up one of these buttons, I can get it to do something. So I'm going to carefully press one of these. Okay, so it's just turned on. Can't see it very well in this light, but it says on. You turn this light off a minute, so you can see. There we go. So it's now on, and just seeing if I can feel any warmth on the inside of the container here. Oh yeah, it's getting warm. Yep, it's getting nice and warm. So it's definitely turned on. This here I think is to up the time, so I'm putting up this is now the hours that it will cook for, and then currently it says it's on high. This LED indicator says it's on high, so that's now, let's press it again. Now it's on low, and now it's on keep warm. So it appears to be functioning. This is the off switch, so there we go, it turns off. So it's actually functioning fine with that 30 ohm resistor in there, so I'm inclined just to leave that 30 ohm resistor in there. I don't see why it's going to harm anything. I might order some 24 ohm resistors anyway. I should order some just to keep them in stock, but for now that looks like it solved the problem. So it was that 24 ohm resistor that had died, and that's all it was that was preventing the thing from working. So I think I'm just going to put that resistor in there permanently for the time being. Get some 24 ohm resistors, and in the meantime see how this behaves, and go from there. So I soldered that resistor in permanently now, and I'm going to give this a trial run, see how it behaves. I think it'll be fine, but I am going to order some 24 ohm resistors just in case, and so I'm going to reassemble this now. I put these two screws back in to hold the printed circuit board in place, and the heatsink sits down at the bottom there, and out the way of everything. So I'll put this front panel back on. Hopefully it goes on easier than it came off. Actually it went on very easy. Just shows you, just wants to be stubborn coming apart. So I've got to put the screws back in this now to hold this front panel in place. And if I remember, there's three screws that are going to hold that in place. And let's see, I've got a selection here. I don't remember which ones. So these bigger ones here are for holding the whole thing in place, along with that one, and that one. So that's the four that hold that in place. And we've got three here. 1, 2, 3. That will hold this back together. And these two here hold this panel down the front, on the inside, and down these two holes, which you can't see, those two holes. So yeah, we've got all the screws. So these are the three now that I've got to put in to hold this plastic unit together. So the 3 screws are back in place, holding that, holding these 2 pieces of plastic together. So that's these are really awkward to get in and out because you don't have much room to manoeuvre with the container for the pot. So, and you don't get much leeway for cabling either. So they're not the easiest screws to get in and out. But anyway, they're back in now. So I've got the 4 screws back in place, holding those white pieces, which hold the screws at the right angle to hold the front panel back. And this has to be one of the hardest things to take apart and put back together again, because all the time you're holding things in place to not stretch the wires and break the element, etc. So it's really a pain in the butt, but anyway, nearly done. So I've got to get these supports, the standoffs, back in place, and also take the dent out of that thing. So I can't really hammer it out. It just wouldn't be realistic to try and hammer it out, so I'm going to have to try and push it out by hand, see if it'll straighten out, and just do it by hand. I don't think there's any other way to do that, so I'll do that next. So I've got the standoffs, I got the thing upside down and got those standoffs and washers back in place, and I just need to locate the bottom half of this, of the top of the bolts, and somewhere there we go. Oh no, that's not in. It was a minute ago. Come on, you got a fraction of an inch to go. So you want to go. Oh, there we go. Now that's it. That's in place. That one's in place. I can feel all the way around that the rest of the body is in place. I pushed the metalwork. Oh, it's not quite set. Not quite set in properly. Looks like I might have to turn that over once I get the washers and the screws started and relocate all that properly. the metal work, that's where the dent was. So I've pushed that out as best I can. It's not a great job, but it's better than it was. Okay, these bottom nuts are back in place, and the bodywork is all back in place. So could do with a bit of a clean, but not too worried about cleaning it. Looks like it needs a Brillo pad or something to get some of this spillage cleaned off here. But anyway, the thing's back together, and time for another test. So I'm going to plug it into the isolation transformer and see what happens. Hopefully it powers up okay. Well, that's looking good so far. There we go. Okay, so mode on, high, low, keep warm, and then we can increase the time, reduce the time, and so forth. So yep, everything seems to be functioning. And off. Yep. And let me just check that it's actually getting warm. Yep, it's getting warm on the inside. And so it looks like we've fixed it. I'm going to clean this up and clean some of this dirt off it. It needs a good clean. Probably wipe it over with some isopropyl alcohol, get all this grease and grime off it, and then test it and see how it goes. It looks like it's working now. All seems to be doing what it's supposed to. "12 hours maximum on high, on low, or keep warm, and we'll also reduce the hours as required." So yeah, it looks like it's done. So anyway, thanks for watching. If you liked the video, give me a thumbs up and subscribe for more videos. Thanks again. Bye for now.